This question is about horizontal circular motion of a ball in a bowl. And in this question, we will not only found a resultant force, but also the reason that why this ball will keep moving in the same horizontal circle and its velocity. This question is taken from 2018 May time zone 2. Okay. So, first of all, in this question, what they say that it is moving in a horizontal circular path. All right. And a normal force is also shown in the same diagram, and which makes an angle to the horizontal and state the direction of resultant force. So, before I answer this, I want to tell you one concept that for any horizontal circular path, the object will have the resultant force will be always along the x-axis, all right, like this. So this will be our resultant force if our chosen rectangular coordinate system in which we are giving this as x-axis, then the resultant force will be always horizontal, all right, in this horizontal plane. And secondly, when we say an object is moving in a horizontal circle, it means that its resultant force, as I told you, is horizontally. It means that there is a no force along the y-axis. Very important point. There is a no force along y-axis, which means there's a no acceleration along the y-axis, which in other words we can say that the forces along y-axis in our this rectangular coordinate system are balanced, which we will use later in the form of equations as well. So in any horizontal circular motion, either it's a mass attached with a string, I'm talking about conical simple pendulum, or it is a ball which is moving on a table surface in a horizontal circle. These, in all of these motions, the resultant force will be on a horizontal axis. So here we will answer that the direction of resultant force is horizontally, at this point it is horizontally rightward. You should not say towards the center of the bowl, we should say horizontally rightward. So our next question is, on this diagram construct an arrow which shows the correct length which represents the weight of the ball. So when I told you there is a net force along y-axis is 0, all right, it means that in this diagram, because we know the weight is always vertically downward, but how much long vector you should draw, it all depends upon the vertical component of the normal force. That's the second force exerted on this ball. So basically, if you will draw a very long vector, then it will not cancel out this component of the normal force. All right, so this component, if it is 20 newton, then it should also be 20 newton, so that all of the force must be horizontally rightward. So that's why what should be the correct length, we should draw up to that extent, such that I told you that this is a gravitational force mg. Okay, now in the next diagram, if I show you, so let's see it in more depth. I'm just drawing that segment where this ball is in contact with the surface of the bowl. Alright, at this point, because the bowl surface is pushing the ball normally in this direction, means that at 90 degrees in this direction, 90 degrees from the surface, but it's making an angle theta with horizontal. So this is a normal force, but at the same time we know that there's another force that is vertically downward, that is mg. Okay students, so as you can see that this is our horizontal circular path in which the resultant force must be horizontally rightward at this point. So this is our rectangular coordinate system. This is the y-axis, this is x-axis. So at this moment we will break down the normal force into its components. And what are the components? We will have a two components. One component is a x component, which should be n cos of theta, and the other component is n sine theta. All right, so n sine theta is completely balanced with this vertically downward acted force equals to weight. Okay, whereas don't you think that n cos theta is directly towards the center of the circle. This is a center of the circle. And secondly, it is not balanced by any other force. So if it is not balanced, then we can execute Newton's second law, and according to that we can say that this is a resultant force. So when we will apply Newton's second law, F is equals to ma, so basically we are going to apply in the along the two axes of our Cartesian coordinate system, right? The one is fx, which is not equal to 0. We have just seen that n cos of theta is equals to ma. All right, and in fact this is our centripetal force. All right, so we can call it F. As you see in the next part, this is written as F, the net force. So I'm going to write it F. Okay, but remember, this F is the centripetal force, whereas this is a Fy, the sum of all forces is equal to 0, which means that the upward force, which force, n sine theta, is balanced by mg. So we can say n sine theta plus into minus mg is equal to 0, which means that n sine theta is equals to mg. So dear students, this is a one equation, first equation that we get, and this is the second equation that we got. Okay, so in a question number 3, as you see, you have to derive F is equals to mg over tan theta. All right, so you see there's a no normal force shown here. It means you must eliminate normal force, this symbol. All right, which we can only do in the case if we divide these two equations. All right, we want to cancel out the normal force because we do not know about its value, its magnitude. All right, so what should we do? Let's divide n sine theta over n cos theta is equals to mg over F. Okay students, so this is going to become tan theta is equals to mg over F, and finally F can be written as mg over tan theta. Okay students, in the next question they are saying if you are given the radius of the ball 8 meter at this point and the angle, determine the speed of the ball. Okay, now speed is constant because this is a uniform horizontal circular motion, so the speed is a constant magnitude. But look at the velocity, right? If it is moving in a counterclockwise circle, so then this is a direction of the velocity at these 2 points. Okay, how can we find out velocity? If you notice, we have the two equations, or in fact, why not we use this relation over here? Okay, you remember I told you that the F is a centripetal force, which they also say net force. So net force is a centripetal force. Why? Because it is directly towards center, only on this criteria, on this basis. All right, so now I'm going to write here mv square over r is equals to mg over tan theta. Okay, so you have to cancel mass on both sides, and v square will become equals to rg over tan theta, and then the speed at in this particular, in this horizontal circular motion, we are going to find its value very soon, rg over tan theta. So students, this is a formula for speed in any horizontal circular motion in this bowl. I'm not talking about specifically this one. Even if this is a this larger horizontal circle or this smaller horizontal circle, you can apply this speed formula because angle will change. All right, I will show you with the help of diagram also. Let us find its speed value. So I'm going to put the values. Okay students, before I put the value, don't do one mistake, that we know that this is the radius of the circle, right, which we are calling small r, but we are given the radius of the bowl. It's not a radius of the circle. All right, so radius of the bowl is 8 meter. So what is the radius of the bowl? Actually, radius of the bowl is this distance. All right, That's why in the first answer you should not write towards the center of the ball, because center of the bowl is this point. All right. So this distance is 8 meters, angle is 22 degrees. So if you want to find radius, so it is equals to 8 cos 22 degrees. Now if you plug the values, then it will give you the correct answer. So square root of 8 cos 22 degrees times 9.8 or 9.81 divided by tan 22 degrees, and your answer will be equals to 13.4 meter per second. That is the speed at this point. Okay, so now the last part, like I have just answered the circular part of this whole question, right? So I will answer the other questions in the next video about that topic specifically. In this question they say either this ball can move on a horizontal circular path of radius equal to the radius of bowl. Okay, I explain you. Look at this diagram. This is a circle of the ball, horizontal circle of the ball, which is, and its radius you have seen is 8 cos 22, is not the radius of the ball. It is not 8 meters, it is 8 cos 22. Why it is not moving in a bigger horizontal circle? I just want to show you that. So students, in this question, they are actually talking about this horizontal circle, in which this is a radius of the bowl that is 8 meter. Now the answer of this question is that it is not possible. Why it is not possible? Because you remember when the ball was here at this point, we have seen the normal force, like this is a normal force, and the weight was, you remember, weight was balancing the vertical component of normal force. All right, and that was equals to n sine theta. Now theta is different. First of all, this theta is 22. This theta will be different when the ball will be here. In fact, this theta will be smaller. And secondly, the weight that was supporting, or that the weight that was balancing the vertical component of normal force at this location, it will not happen at this location. All right, because you know the weight cannot change. That's why this weight will not cancel out the vertical component at this point. So that's why it is not possible. Weight and component of normal force, vertical component in fact, will not be balanced. In fact, just last minute, I'm telling you that the normal force at this point is first of all a smaller vector in magnitude also. And the normal force at this point has a larger magnitude. Okay. Secondly, dear students, if you see this angle is small. So if you draw its component, the vertical component, that is a very small value. All right. But what about the weight? Weight is already the constant value downwards. So you see now we are getting a resultant force along y-axis also, which will pull or which will push the ball down. Okay, so it will not be able to retain its horizontal circular motion at the radius of the bowl for this specific speed. So I hope you understand this question.